We are live at the European Spaceport in French Guiana, looking across at launch pad number 4, where Europe's newest rocket, Ariane 6, is getting ready to lift off for the 4th time. Welcome to our YouTube live Road to Space. On board, a satellite to watch over our planet. It is Sentinel-1D, part of the European Union's Copernicus Earth Observation Programme, and it's up there in the top of our rocket, waiting to lift off. Mission control is about 16 kilometers from that pad. That's what it looks like. We are overlooking mission control here in our commentary box. Inside the fishbowl there, that protective glass, the operational teams going through these final preparations now before launch. I'm Katie Haswell, and joining me here in the commentary box is Samuel Rogers. Samuel is the Head of Advanced Studies at Arianespace. That makes him a real rocket scientist. Thank you very much for being with us, Samuel.
Thank you, Katie. Hi all, and it's a great pleasure to be here with you to commentate this launch live.
And we've got some onboard cameras today, so we're looking forward to some really good pictures, aren't we?
Yeah, we have 3 cameras on board, and we hope to get some very nice views of the big steps, the big events as we climb into space, indeed.
So, we have a packed show for you. Samuel and I are going to be with you now all the way through to separating our satellite. We'll be discovering our satellite, of course, Sentinel-1D. We'll also be finding out about operations across the various facilities at the range and in Europe.
Yes, indeed. First we go in the launch zone. We'll see the Ariane 6 launch site, the dedicated area where we do final preparation. It includes, of course, the launch pad, which we see, but also the launcher assembly and the integration building.
And we will see the teams in the Launch Control Center who are responsible for all the operations on the rocket and the pad before liftoff.
Then we'll go to a quick look telemetry team. They are collecting real-time data from the launcher to continuously analyze this data, its behavior along the flight, and to confirm that everything is running as expected.
And we'll also head across the water, across the pond to the European Space Operations Centre, where the teams are getting ready to fly their satellite, to operate their satellite. And of course, we'll be here in the Mission Control Centre, the nerve centre of operations. We call it Jupiter. The teams here responsible for coordinating the final launch preparations and countdown. And inside the fishbowl, let's go now over to David Cavaillolès. David is the CEO of Arianespace and the head of the flight desk. David, how are things going?
Well, Katie, I can tell you that here the teams have done an incredible work to prepare this mission and to make it happen. Now all the indicators are green. Ariane 6 is standing on its launch pad ready for liftoff in now a bit less than 25 minutes.
And that's what we like to hear. Tell us a little bit more about our satellite, David, Sentinel-1D.
Yeah, sure. This satellite is part of the Copernicus program of the European Commission, and this is a very important satellite because it carries on board a radar that is extremely performant. With this radar, with this satellite, we'll be able to provide services in various fields, whether it's about maritime surveillance, monitoring and tracking of the icebergs, or to provide emergency services in case of hurricanes or other disasters. So for all these reasons, we are very proud at Arianespace to launch this satellite today.
And deservedly so. And this is the 4th time, indeed, that Ariane 6 is lifting off from the pad here at the Guiana Space Centre. Why is that important?
Well, you know, with Ariane Group, with all our industrial partners, we are engaged in an incredibly fast, in an incredibly steep ramp-up. We are going super fast, and it's going in the right direction. And what I can tell you is that our clients count on us to deliver their missions and to launch their ambition. So this is really important, and everybody here is totally committed.
And wishing you now the very best, David, and the teams for the launch as we get closer. David Cavaillolès, thank you. So as David said, everything is green, everything is go for launch. Status panels there on the left-hand side of your screen. You can see them there, all the various systems across the base sending their status here. And Ariane 6 and Copernicus Sentinel-1D is scheduled to lift off in 21 minutes and 15 seconds. What's going to happen after that, Samuel?
So then, first we'll lift off from the French Guiana here in South America towards north. The liftoff will be triggered by the booster's ignition, but before that we would have fired the main stage engine. The boosters will be separated around 2 minutes and 40 seconds after the liftoff, and then a bit over 1 minute later we'll have the fairing separation, because the launcher would have crossed the atmosphere, so we don't need it anymore. Then after 7 minutes and 37 seconds, then the main stage will have kind of finished its job, so the Vulcan engine will be shut down and the main stage will be separated. Then we'll wait a few seconds and we'll fire the Vinci upper stage engine. It will be ignited for the first time. We'll have 2 burns for this flight, but this will be the first one. It will burn for about 12 minutes and will allow to reach the targeted orbit. Then after orientation maneuvers, once in contact with Svalbard station in the north, close to North Pole, we'll separate our passenger Sentinel-1D. We'll then have a long coasting phase going down Eastern Asia and over Australia, where we will have contact with New Norcia ground tracking station, and we'll continue our coasting phase to get back over our heads, reaching then the contact with Gatineau station located in Canada. And this is the place where we will perform the second Vinci upper stage engine ignition, a short one, and this boost will enable to slow us down. It will be followed by stage passivation, and all of this will lead to a re-entry of the stage above Indian Ocean. This is really key to avoid leaving any debris orbiting the Earth.
Absolutely, very important indeed. And once Sentinel-D is released, it'll go through a series of tests and commissioning before starting its very important job. Because Sentinel-1D is part of the world's most advanced Earth observation system for watching over our planet. The European Union's Copernicus program, managed by the European Commission.
Yes, indeed. And there are actually 12 families of satellites in Copernicus. Sentinel-1D is the 4th satellite in Sentinel-1 family, as you can guess, with the D letter, ABCD. We launched, and you remember, of course, its twin, Sentinel-1C, last year in December 24, on board a Vega C rocket. We had the pleasure together to comment the launch live. Yeah. And they will orbit with 1D in tandem, 700 kilometers above Earth, capturing high-resolution radar images day and night, and of course in all weather conditions.
And to do that, of course, the key word is radar. That's the technology that allows it to monitor not just the land and oceans in all conditions, but also disasters.
Tonight in Kourou, history is unfolding under the stars of French Guiana. Combining innovation and engineering brilliance, Ariane 6 is writing a new chapter in Europe's space story. And riding on top of this powerful launcher is Copernicus Sentinel-1D, the latest eye in the sky for our planet. The Sentinel satellites are part of Copernicus, the Earth observation component of the European Union space program. Copernicus is managed and funded by the European Union, with a partial contribution of the European Space Agency, ESA, entrusted with the space component. As one of the most widely used radar systems in the world, the Sentinel-1 constellation provides crucial data for science, safety, and climate resilience. Sentinel-1 data are a service to communities worldwide, designed to truly benefit society. After natural disasters like floods, its imagery helps guide emergency services. At sea, it supports maritime activity, tracking ships, and monitoring coastal zones. Over icy landscapes, it keeps a close eye on glacial movements. In the fields, farmers use it to track soil and crop conditions in real time. And across Europe, decision makers draw on its imagery to shape the future of environmental protection. Flying in tandem with Sentinel-1C, Sentinel-1D will replace Sentinel-1A and ensure the continuity of Europe's radar vision. Equipped with upgraded electronics and enhanced power systems, it will scan Earth 14 times a day, delivering sharper images and faster data than ever before. Built by a consortium of more than 70 companies, led by Thales Alenia Space and Airbus Defence and Space, Sentinel-1D weighs around 2.3 tons and carries a C-band synthetic aperture radar capable of capturing images in remarkable detail at a resolution down to 5 meters. Orbiting nearly 700 kilometers above the planet, it will help ensure the seamless flow of vital Earth observation data. As a strategic asset, Sentinel-1D reinforces the EU's autonomy in Earth observation. In a moment, it will rise to space, ready to deliver knowledge that connects us all.
Indeed, and that's planned for just over 15 minutes' time. Sentinel-1D sitting comfortably up there at the moment, though, inside the rocket, waiting patiently for that liftoff. And the teams who are going to be operating it, or flying it, if you like, we saw them at the beginning there, they're standing by their Mission Control Centre at the European Space Operations Centre in Germany. A short while ago, the Flight Operations Director took the roll call, where each team confirmed they were ready for launch.
All stations, this is the OD on the briefing loop. This is the Sentinel-1D roll call. All positions that respond to the OD on the briefing loop, quoting their call signs, followed by their go, no-go status. SOM.
SOM, go.
Data handling.
Data handling, go.
AOCS.
AOCS, go.
Power.
Power, go.
Spacon 1.
Spacon 1, go.
Spacon 2 analyst.
Spacon 2 analyst, go.
Timeline.
Timeline, go.
Project rep.
Project rep, go.
Project support.
Project support, go.
Software coordinator.
Software coordinator, go.
Software support.
Software support, go.
Flight dynamics.
Flight dynamics, go.
OM.
OM, go.
S-track.
S-track, go.
Collision avoidance.
Collision avoidance, go.
Scheduling.
Scheduling, go.
Thank you, everyone. This concludes the S1D roll call. ESOC is go for launch. From now on, any change in the ground segment status shall be reported to me immediately. Thank you.
And here at the Spaceport, we are also go for launch. Now, at the top of the rocket, there is a logo. It's for the city of Mulhouse, part of the group of Ariane cities representing the cities and industries involved in Ariane 6.
En tant que président de Mulhouse-Alsace Agglomération, je suis fier de porter la présidence de la communauté des villes Ariane aux côtés de Eiffage Énergie Système, industriel historique de notre territoire, pleinement engagé dans le programme d'Ariane 6. Au cœur de notre ADN, nous avons réussi à développer une véritable culture partenariale avec les acteurs économiques du Sud Alsace. Nous facilitons et accélérons le développement de projets d'envergure dans les domaines de l'industrie du futur, de l'intelligence artificielle, des nouvelles énergies et des transports de demain. C'est notre force et notre spécificité en Europe et à l'international.
Tout au long de l'année, les 39 communes de notre agglomération M2A se sont mises en orbite, bien sûr avec l'ensemble de nos partenaires scientifiques, culturels et économiques, pour proposer un beau programme d'action. Il m'appartient de saluer ce très bel engagement et de remercier l'ensemble des acteurs pour ce beau projet.
Conférence. ateliers, expositions. Au total, nous avons déployé plus de 120 animations autour du programme spatial européen et d'Ariane 6. À travers la communauté des villes Ariane et de notre programme Le Spatial et moi, nous avons fait rêver plus de 280 000 habitants de notre agglomération mulhousienne.
The weather might be a little bit chilly in Mulhouse right now, but here at the Spaceport it's clear blue skies, not a drop of rain in sight, Samuel. We do have to keep our eye on the weather though, don't we?
Yes, indeed. We don't really fear the rain for the launcher, but we are monitoring several parameters. One of these is the wind. We call it high altitude winds. It's because we look at between 10 and 20 kilometer altitude, and we want to make sure that the wind speed and direction remains below a certain limit. It's not that the launcher could not withstand it, but mainly for safety reasons in case of launcher malfunction. And here you can see the weather station here in French Guiana, where they are measuring a number of parameters inside the atmosphere using balloons, as you can see, measuring humidity, temperature, for instance.
And the weather status panel has remained green here at the Spaceport, and we had the final weather check there at -10, T-10. So that's good news. We are green for launch with the weather. But we do have to monitor lightning as well, don't we?
Lightning, yeah, on the ground, as you can see in the launch zone, we have 4 giant masts which protect the launcher. But during the ascent, we want to avoid the launcher to be hit by lightnings. This would actually damage the avionic equipments within it. So that's why we want to avoid any risk of lightning, and we do verification before launch.
Now, we've built a brand new cargo ship to transport the parts of Ariane 6 to French Guiana from Europe. It's called Canopée, and it's really incredible. It's way more than just a cargo ship. It's quite revolutionary because it's actually got sails.
Yes, indeed, it's kind of a hybrid cargo because it uses both fuel and wind to cross the ocean. And wind thanks to the 4 pair of sails, as you can see on the screen. It was a great adventure to develop and produce such a ship. It started 6 years ago, and it's a giant step to reduce carbon emissions for such type of transatlantic crossing. It's, as you see, can transport launcher elements, but not only, also satellites, as we did last year for something.
And it's already saving, I believe, 40% of fuel.
Yeah.
So the wind power, so that's really amazing. I believe it's going to set to transform the shipping industry. And for this mission, Canopée arrived in French Guiana, a few weeks ago?
Early October.
Early October.
Actually, it arrived on the 3rd of October, transporting the rocket stages or rocket elements, as we named them. You can see the containers here. The biggest is with the main stage inside, and the smallest is the upper stage. They were then transported by road to the spaceport, unpacked, and then we proceeded with the horizontal assembly of the main and upper stages in the launcher assembly building. Then mid of October, we transferred this assembly, the core stage, to the launch zone, which is located 800 meters away. We did that with the automated guidance vehicle, as you can see. Then the central core was lifted up inside this giant mobile gantry and placed below this gantry on the launch table. And finally, the boosters were transported on their own transportation means and were integrated, attached to the central core. On passenger side, our satellite Copernicus Sentinel-1D arrived in French Guiana by plane mid-September. Then it was prepared for about 5 weeks with a number of checks. After transportation, you want to be sure that everything is working properly. Then it was filled with propellants mid-October, and then combined operations with launcher elements started on the 22nd of October with integration on the payload adapter, and then it was transferred to the encapsulation building where it was assembled to the launch vehicle adapter and encapsulated below the fairing. You can see 1/2 fairing here. And last week, the satellite and fairing stack was transferred to the launch pad and integrated on top of the launcher. Over the last days, we had safety operations, arming of the pyro systems, pressurization of helium systems, and today we started the final countdown.
And that final countdown started about 8.5 hours ago. Lots and lots of operations during that time. What's been happening?
Yes, indeed, lots of operation. The main step of it is the mobile gantry rollback earlier today, so 8.5 hours before launch. And then we have...
The mobile gantry being that big building there behind
where
the rocket.
The launcher is assembled. And then we have flushed all the propellant line to avoid any leftover humidity in preparation for the cooling of the lines and then start of the fueling of the tanks. And this started around 5.5 hours before the launch. And of course, before fueling operations, we check the weather condition and the weather forecast for the launch to be sure we are fueling for the launch attempt. And in parallel, we were doing pressurization of the systems, running electrical checks and armings, and getting the telemetry and the radars ready for liftoff. So now we are in stable and safe situation, waiting for the start of what we call the synchronized sequence.
Indeed. The all systems go report will allow the automatic sequence to start, waiting for our range operations manager. Today it's Jean-Frédéric Alassa to announce that.
À tous de DDO, attention pour la séquence finale lanceur. Top, à 0-5 minutes.
So we are now 5 minutes to launch. The synchronized sequence, or automatic sequence, as we also know it, has started. The last 5 minutes of the countdown. Ariane 6 now becoming progressively autonomous, and there are lots of very finely timed operations happening during this time, aren't there?
Yes, indeed, and all of these operations are very precisely timed. They are combining system checks, pressurization of the cryo tanks, activation of different systems and valves. And the control of operation, as you said, is gradually being handed over from the ground to the computers of the launcher. And it will be actually the launcher onboard computer who will actually send the main engine ignition command. As you see, you can see the nozzle of the Vulcan engine we are talking about. And the same computer will check that it's working properly before actually sending the order for ignition of the 2 boosters, which will lead to liftoff, of course.
Yes, indeed, indeed. And we have a number of control rooms on the job today. We've got some in Europe, of course, but we also have, well, obviously we've been seeing mission control here at the Space Centre, a bit like air traffic control, if you like, at an airport. And then we also have launch control, who deal with everything to do with the rocket and the pad, a bit like the cockpit in the plane?
Yes, indeed. It's the place where the team are getting the launch pad and the launcher ready for liftoff. So these are operational teams sending various commands to turn the launcher avionics on, for instance, to fill the propellant tanks, to pressurize the tanks, and to do all the tests which are needed to confirm that the launcher is ready for launch. And behind them, behind the glass window, we have another team who is monitoring all these operations closely, making sure that all the parameters are expected. They are following physical parameters such as temperature, pressures, electrical currents, etc. And we have another team in Europe backing all of this and following the launch from across the ocean.
Well, very important to have as many people on the job as possible. Getting close now, laser focus in all of these different control rooms as we get close. 2 minutes and 39 seconds and counting. Let's just run through a couple of things to watch out for, Samuel, at launch. Can you see at the top 3/4 of the rocket 2 yellow bits? They are actually the ends of the cryogenic arms, which are clamping onto the top of the rocket and feeding very, very cold fuel into the rocket.
Yes, indeed. They are pumping liquid oxygen and liquid hydrogen into the tanks of the upper stage. And to keep them liquid, as you said, we must have temperature, very, very low temperature. We are talking minus 253 degrees for liquid hydrogen and minus 180 for liquid oxygen. So you can see some smokes on the screen, and that's due to this reason. And we actually top up to almost the last instant, and at liftoff you will see these yellow arms being detached and retracting away from the launcher to clear the path.
Good view of them there, isn't it?
Very nice
Going
shot.
from the gantry to the rocket. Very, very
And we
cool
can see
views.
also the umbilical links in between the mast on the right and the launcher on the left, which are, as a baby with his mother, they are feeding the launcher with electrical power, air conditioning, etc. And they will deconnect automatically
at launch. And we've seen, just briefly mention the Vulcan engine, we've seen that earlier, and that is going to switch
tous de DDO. Attention pour moins 1 minute.
7 seconds before launch.
Top, agissez pour moins 1 minute.
We are 1 minute to launch. Our very best wishes now to all the teams who have been working so hard for today. Good luck, everyone.
Yeah, have a good ride, Ariane 6 and Sentinel-1D.
À tous de DDO. Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Allumage de ESR et décollage. La propulsion est nominale. Début de la manœuvre en roulis. Le pilotage calme, la trajectoire est nominale, les paramètres à bord sont nominaux.
Copernicus Sentinel-1D has started its journey on board Europe's newest rocket, Ariane 6, hauling itself against the gravity of our planet.
Amazing views, wow.
Sensational images from our onboard cameras.
Wow.
Right now, we are burning 3 engines. Our range operations manager is telling us that everything is going normally. We can hear the rumble.
I can feel the wall of the room shaking.
We can indeed, as it flies over.
Flying over. Wow.
You can see there the 2 boosters are doing all the work right now, Samuel.
Yeah, almost all the work. 85% of the effort is indeed brought by the boosters. It's a giant piece of power because they are filled with 142 tons of propellant each, and we are burning them in a bit more than 2 minutes. So we're actually burning around 2 tons per second here. That's really massive.
That's a lot of fuel, and we got a great shot of them there, those 2 dots. He's telling us that everything's going normally.
And we should potentially see the booster separation that should arrive soon. And you can see even the third spot of the Vulcan engine at the center of the 2 nozzle of the 2 boosters.
That's right, the white dot is the Vulcan engine, and there we can see the 2 boosters now being jettisoned.
See that 2 boosters, 1 up, 1 left down, moving away from the center stage.
And they detach from the rocket thanks to a pyrotechnic device, which is made by a company called Pyro Alliance, who are real experts in this.
Indeed, they are providing pyrotechnic systems, and they are used to separate the rocket, to separate rocket elements, as we see on the screen, like boosters. We used them for the previous step. We'll use them again in the next steps of our launch, as you'll see. Nice, super nice videos here from the onboard cameras where you can see the boosters moving away.
We get those images for technical reasons from the onboard cameras, just a few seconds delay. So there we can see those 2 boosters having fallen away, and the range operations manager telling us everything's going normally and according to plan. Got our satellite tucked away inside the top of our rocket, still being protected at this point by the fairing.
Yes, indeed, and the fairing has several jobs. First, of course, is to protect the satellite on ground from the dust and humidity of French Guiana.
And we've just had confirmation there that we've actually separated our fairing.
And this is because when we cross the atmosphere, it protects the satellite from the friction with the air that generates heat and vibrations. And now, as we are over, we've passed the atmosphere, we can jettison in.
And you can see there,
that's nice.
It's actually moving, isn't it? It's called the breathing mode.
Exactly. This is due to the effort of separation system, which kind of deforms the fairing, and it generates an oscillation mode. We call it breathing mode, indeed.
Indeed, and it's all part of the plan, flexing as it falls. He's telling us the propulsion is normal. Everything's going well. Everything's going according to plan right now. And our camera looking down our rocket. On the top right-hand side of your screen, that's the trajectory. The green line is the planned trajectory, and the white cross is the actual position of our rocket. And you can see there our altitude. At the moment, we're 146 kilometers above our planet and climbing. The distance is our distance from the planet if you were to draw a straight line, and our speed on the right-hand side. Vitesse is the French word for that. So we're burning the big tank of fuel on the main stage, Samuel.
Yeah, it doesn't seem to be so big seen from onboard cameras, but indeed it's quite big. Its height is 32 meters, and its weight is 23 tons. It's not so big when you compare the mass of it with what it's containing. It carries 154 tons of cryogenic propellant, so it's quite efficient in terms of mass versus propellant inside.
And we can see on the bottom right of your screen, that's the 3D animation or the CGI images. It's an animation of what's happening in space. So that gives us an idea of what it looks like up there, the Sentinel-1D satellite attached there to the top of our rocket. Now we're getting closer now, about 2 minutes away from the next big event. You can see the events on the left-hand side of your screen. The next big event will be the separation of that big tank of fuel, the main stage.
Yeah, indeed. The guidance algorithm inside the onboard computer will detect that we have reached the right orbit for this instant, and then it will send the shutdown command to the Vulcan engine and then jettison the main stage.
And separating each section of the rocket may look simple when you see it on the animation, but actually there's an awful lot happening up there, isn't there?
Yeah, it's
a very critical moment.
It's clever stuff here, yeah, indeed, because when you separate the stage, it must be quick enough, but it needs also to be very well mastered, because you don't want to have any collision. And here, you remember, here to do that, we use pyrotechnics again, as we mentioned, Pyro Alliance. Earlier, we are using their technology again for this type of stage separation. They have developed a mild detonating cord, which is a detonating component. It's inserted into a tube which deforms and then cleanly breaks the part that relates the upper and the main stage. And then, once cut, we gently push the lower stage with a set of springs, and this to ensure sufficient clearance in a short amount of time, and because then we need to fire the upper stage engine, so we want to be sure the lower stage is separated and sufficiently far away.
It needs to be quick and it needs to be clean.
Indeed.
And Pyro Alliance has been supplying these mild detonating cords for many decades, and they've actually delivered a total of more than 100 kilometers of cords.
Which is huge when you realize that for one launcher we're talking meters, not kilometers.
Extinction Vulcain.
We have confirmation there that we've switched off the engine and jettisoned the big tank there, the main stage.
Allumage du moteur Vinci.
And we have confirmation that we have now switched on
and look on the picture. I think the video will see the main stage separation shortly. Yeah, here it comes. Nice view. This is seen from the lower part of the Vinci. Nice.
Fantastic image there of it being jettisoned.
And see, jettisoned and then tilted slightly so that the Vinci, when ignited, doesn't throw a propellant to the rear bulkhead.
So we're launching a satellite to monitor our planet today, but satellites do lots of other things.
Yes, indeed, they also help us to any kind of things, like connect with each other, like navigate our planet, like protecting people and animals, managing disasters, helping the armed force in combat. And when you think about telescopes and space probes, they help us understand our universe.
Indeed, but first of all, you've got to get them into space, and that's where Arianespace comes in, because they are Europe's leading provider of rocket launches. And I think it's fair to say that they don't just launch satellites, they launch people's ambitions.
The launch starts the moment you partner with us, as we go above and beyond to understand your world from orbit. Everything you've ever imagined, the value you bring home to Earth, all the lives you seek to improve. So, whatever your goals, however far you want to go, your success is our mission. More than rockets, we launch ambitions. Arianespace. Launching ambitions.
Launching ambitions for each and every one of us on Earth. I think it's fair to say that space is literally transforming our lives. And if you think about it, since we first launched Sputnik, that was the first satellite, I think it was back in something like 1956, we've turned the skies above our lives, if you like, into a giant workplace, a great big working zone in space.
And satellites keep our day-to-day lives taking over.
They do. Yeah. If we switch them all off, our life would be a very, very different place. But being able to monitor our planet from space is particularly important given the climate emergency that we're facing. I mean, after all, Earth is our home. And if we want to protect it, we need to understand its processes.
Yes, indeed. And that's why satellites are so important, because from space you can clearly see things that you can't see from ground. And you can get constant data over years and years, and data that no one can argue with, like, for instance, measuring the melting of ice caps from space. There is no way to argue with the data you generate from that.
Indeed, you can get information from local people, but the satellites can give you the hardcore data. And Europe actually has huge expertise in building Earth observation programs, and the Copernicus Sentinel satellites, well, they're a great example of European partnership.
Yeah, exactly. It was a real collaboration between the European Space Agency, the European Commissions, and a huge network of industries.
Yep, and the industrial prime contractor for the Sentinel-1 series, for those industries, is Thales Alenia Space, who have led a team of over 60 or 70 companies across Europe.
That's quite a team, and they have contributed to design and build the key systems which were engineered in Italy. So each Sentinel-1 is based on Thales Arianespace Prima spacecraft bus. So if you wish, the spacecraft bus is a bit like the skeleton of the satellite, and they developed this for the Italian Space Agency.
And just like its twin, Sentinel-1, actually, I believe it features a world first, is that right?
Yeah, indeed. There is a patented mechanism which safely detaches the radar antenna. And it does so on re-entry, helping to reduce the space debris.
And that's hugely important because, of course, space is very busy at the moment, and we need to try and reduce debris as much as possible. And since the first Sentinel-1 was launched, that was back in 2014, the Sentinel-1 family has delivered a few numbers for you here: 50 million gigabytes of data. That's a lot of data. To over to over 600,000 users worldwide. That's a lot of users worldwide. So the Sentinel-1D is going to be continuing that legacy. That's important. Watching over Earth, one radar pulse at a time. So let's get back to our flight. We are 13 minutes and 15 seconds above our planet, our altitude 593 kilometers and climbing. We're looking here at the Sentinel-1 satellite. Samuel, just talk people through that. At the very front there, that's actually the radar all folded up, isn't it?
Exactly, yeah. On the side of it, the grey, plus on top and bottom, indeed are the parts of the radar antenna folded, and then on the grey side, folded solar panel of the satellite you can see, and it's attached to the launcher thanks to these black cones, one of them being the launch vehicle adapter, and then it's below it's the upper stage, this white cylinder, and below it the Vinci engine.
Pilotage toujours calme, propulsion nominale.
And as you can see, there is not much left from what we had on ground.
But what is left is very important, because it's the upper stage with its Vinci engine, and it does a very, very important job.
Yes.
Today it can switch its engine on and off a number of times, but today we're just using it once, aren't we?
Yeah, to inject Sentinel-1D, we'll just use one burn, one firing of the upstage. And you're right to say that usually we tend to do it with 2 or more boosts, and for this type of orbit.
Acquisition de la télémesure par la station Gatineau.
Okay, we'll be back on that, but that's an important news. And we do so with just one boost because Sentinel-1D is rather light as compared to Ariane 6 capacity to get to this orbit. So this is the reason why we can do it in just one step instead of 2, and as a result the mission is a bit shorter as well.
So we picked up the signal back there at the tracking station Gatineau, which is on the east coast of Canada.
Yep.
And Gatineau is a very beautiful place. I'd say that the teams there at the tracking station are very lucky to work there, particularly in the fall when you've got all those gorgeous colours of the trees. It's very stunning, with a great big dish, which is what tracking stations have. Can you imagine driving to work, Samuel?
Yes.
Every morning with that lovely view.
Nice conditions, I guess, yeah.
Yeah.
And you've seen as well the big dish, the big antenna on that picture. So this is the antenna that points the point in space where the launcher should appear in the Canadian horizon, and then it's following Ariane 6 across the sky as it's crossing the whole Canadian sky, and then
Trajectoire nominale, les paramètres à bord sont nominaux.
It recovers all the data that Ariane 6 is sending, and then the Gatineau team send the data back to Galio, where another team here is located to digest, analyze.
And you had a good picture of that back there. You can see the Galio tracking station here at the Space Centre, and then above it, north of it, the Gatineau station, so that could show us the flight path. But
this is a bit the relay in between the two ground tracking stations.
Yeah. Indeed, and that network of tracking stations extends really all the way along the flight path. So as we fly out of the range of one, as you say, we fly into the range of the other. And they relay that information here to the CVI at the Quick Look telemetry team.
Yeah, indeed. I just confirmed that we lost contact with Galio station, which is normal, which is located here in French Guiana. And this team is collecting real-time data, analyzing what the launcher sends. They include the status of the engine, the trajectory, the flight control, and they are comparing this live set of data from the rocket to what was predicted, the prediction, and of course a corridor around it. And this allows them to continuously analyze the launcher behavior and confirm that all is as expected, or detect any malfunction or anomaly.
And the range operations manager is listening in on their comms loop, and once they've confirmed the major events, he can then call those out to us and to the rest of the people all across the entire range.
Exactly.
Our speed and altitude up there on the top right-hand side of your screen. Now we are climbing. We are nearly on our orbit. We're, 689 kilometres above Earth. And we are travelling incredibly fast. Samuel, give us a bit of an idea of what 6.77 kilometres per second is in kilometres per hour.
7 kilometres per second is fast because it corresponds to 25,000 kilometers per hour, so that's super fast. It's 30 times the speed of a commercial standard aircraft. So yeah,
that is fast.
It's fast.
Yes. And if you look at our trajectory up there on the top right-hand side of the screen, you can see we were climbing into space, but now we've kind of plateaued out, if you like.
And this is because we are getting close to the desired altitude to deliver Sentinel-1D, because we were mentioning just below 700, so getting really close, and that's why we are kind of reducing the climb.
He's just said end of the barbecue mode there, which is, as we say in English, does what it says on the tin, which is basically it is twisting, or was twisting, as if on a barbecue, and that's...
To distribute the sunlight over the different region of the launcher and satellite.
Yeah, indeed, making sure that the temperatures stay even all the way around, because of course it's very hot when you're facing the sun and very cold when you're facing outer space. Coming up on the next big moment, that's the switching off of the Vinci engine, coming up in 30 seconds' time. How does it know briefly, Samuel, how to switch it off?
It's the onboard computer which has measurement means to know where it is, and then it can automatically, once he knows where it is, it can automatically switch off the engine, and this is. And we just had confirmation that the upstage engine has been switched off.
And that's how it looks up there on the animation. And so we're now at the right point. The onboard computer has indeed detected this, has switched off the Vinci engine, so we are in the right place at the right time. Now, getting a view there of our satellite attached to the top there. Oh, that's a very good view there. Now, we're actually looking at the solar panels, but around it, to the right-hand side of the satellite is actually the radar. And that is a very clever piece of kit, because unlike optical satellites, it can gather data even in darkness. Sentinel-1D emits a burst of flashes every second, and the satellite can detect those echoes bouncing off the surface of the Earth, and it uses that to create a radar map of the terrain, or the ocean, or the ice, depending on what it's looking at. And that makes it very useful in the Arctic winter. You can just imagine when the nights are long and dark. Well, now, joining me to talk more about our satellite is David Bibby. David is the Copernicus Sentinel-1 payload manager for the European Space Agency, and I'm absolutely delighted, David, that you've been able to come from the fishbowl. David's come out of his operational teams there to talk to us, so thank you very much, David.
Thank you for having me. It's a pleasure to be here.
Well, should we start by talking about the big picture, David, the Copernicus program as a whole, which is made of, am I right in saying 12 families of satellites?
Yeah, that's correct. It's 12 families of satellites. There's 6 of the Sentinel-1 to Sentinel-6 satellites. They're operational, so they're already flying. And then we've got the high priority Copernicus mission satellites, which are in development, or very much in their development phase at the moment.
And of course the Sentinel-1 family is one of the families in the Sentinel, in the 12 families of satellites.
Yes, indeed. It's Sentinel-1 is well, we launched the first one in 2014, as we've seen from the videos, actually, Sentinel-1A.
Little Bird tells me it was launched on his birthday.
It was actually, yes. It was a great birthday celebration. I really enjoyed that. So we launched Sentinel-1A in 2014 on the 3rd of April. It's been in operation for now 11 years. We're now launching Sentinel-1D, which is the 4th Sentinel-1 to launch into the family, and it will continue to provide data, or the high-quality data that we've come to know and love coming from Sentinel-1. So, yeah.
What does the Sentinel-1 family do? What's their job?
Their job is to monitor the Earth. So we've got 2 instruments on board, the synthetic aperture radar, and this takes day and night all-weather images of the Earth, of the planet. So we're not impacted by any weather systems or darkness, and we can monitor the Earth and the oceans using the radar. And we've also got an AIS instrument, which is automated identification of ships. This receives messages from the ships for their ship ID, their velocity and direction, which we can use to track ships and identify them in the oceans. And we can even see these ships in the SAR image. So this gives us a unique capability of using both instruments together.
Yeah, so let's just look at some of the imagery that we've got from the Sentinel-1. He's telling us that everything's going normally and according to plan, so that's good to know. It's done some very, very important work since that first launch in 2014. And we have an image of the Myanmar earthquake. Can you just talk us through, David, what we're looking at? What's the one on the left?
So the one on the left is an image taken by Sentinel-1A on the 27th of March, so it's the day before the earthquake. And you can clearly see the fault line on the right-hand side of the image. This is the line between two of the tectonic plates. And this is...
We're literally looking there at the Earth, a great big crack in the Earth.
Exactly
it's incredible.
Right. So, unfortunately, there was the earthquake on the 28th of March, and we took another image using Sentinel-1C 2 days after that. And then we compare both of those images, and we come up with this, after some processing, we come up with this image on the right. Now, it looks like it's full of nice colours, but actually, if the experts look at this, you can tell how much the Earth has moved between the two events. So it's really useful information. And from this image, you can see that the tectonic plates have actually moved apart by about 1.6 metres.
That's huge, isn't it?
Yeah, it's a large distance, yes. And this information, as well as directing the emergency services to the right areas, can be used in future modelling to improve modelling so that we understand how these are going to happen in more detail later.
So it's really valuable, isn't it? We've also got an image from the Bangladesh floods.
Mm-hmm. Yeah, another capability for Sentinel-1 is to spot flooding. You can see this over a period of about a month, I think, but you can clearly see the riverbanks have burst there in the flooded areas. This allows emergency services to get to the right areas to rescue people, and also, again, it can be used in future modelling to know what will happen in case of floods, to identify floodplains and flood areas so that people don't build properties there.
And this is increasingly important, of course.
Indeed, yeah.
We're seeing more and more floods. Now, you mentioned earlier as well that the Sentinel-1 family are extremely useful for maritime surveillance and detecting ships, oil spills, that sort of thing.
Indeed, yeah.
We have another image here to show that. What are we looking at here, David?
This is a message density map. So each of the ships that has an AIS system on board will send...
Shall we just tell everybody what AIS means?
Automated identification of ships. So it's a system that we use on all ships, actually. I've got this capability to transmit their unique ID, their direction and their velocity. Even when they're not moving, they send this information, and we can pick that up on the receivers on Sentinel-1. The good thing is we can see the ships in the SAR image, and we can see the data that comes from the AIS, the AIS receivers, and you can compare both of those two bits of information to see whether there's any piracy going on. So anyone that's not transmitting will be investigated. Yeah.
And we call those... he's just telling us that we're picking up the signal there at the Svalbard tracking station. That's pretty in the Arctic Ocean. So this is really important, isn't it, for the so-called dark ships who turn off their...
Yeah, exactly right.
Identification system, just on that for that reason, so you can't see them. You can't
no, exactly, and hopefully this will go some way to combat piracy, so it shouldn't be possible in the future, yeah.
Yeah, so lots going on there. So today we're launching a 1D. I mean, we've launched the other three. Why is 1D so important?
Well, 1D is important because it'll join Sentinel-1C, its sibling. Sentinel-1A is 11 years old. It's time to retire S1A, so it will take up the mantle that S1A has been providing up till now. It will continue with S1C to provide the high-quality data that we've been providing for the last over a decade now. Well into the next decade.
So it's going to really give that irrefutable data that nobody can argue with and continue the job, which is really, really important. David, thank you so much. It's been fascinating. Thank you so much for coming and sharing that information with us.
Thank you, Katie. It's been a pleasure. Thanks for having me.
Well, just hearing again from the Range Operations Manager that everything's going well, so that's great. I'm going to send you back now. David's going to head back down to the fishbowl to continue your work there. I'm going to wish you the best now for separation of your satellite. David Bibby, thank you.
Thank you.
So we are travelling now over the North Pole. The tracking station at Svalbard is tracking us. It's a remote Norwegian archipelago known for its dramatic natural beauty, which of course it will be given its location. One of the most northernmost places on Earth where people live. There are lots of rugged mountains. He's just saying we're gone out of the range of Gatineau, but we're already in Svalbard, so that's good. Lots of fields. In fact, 60% of the land is covered by glaciers. So you can imagine that it's home to polar bears, Arctic foxes, reindeers, seals, seabirds. No wonder it's popular with tourists. Samuel's back with us. Samuel, would you like to go to Svalbard?
You want to go there, that's for sure. You want to do all the ground tracking.
I want to go to all the ground tracking stations.
So everything's going well so far. We are getting close to delivering our satellite. Just over 4 minutes. Sorry, I'll interrupt while he's talking. So just over 4 minutes to deliver it. And so, yeah, and currently the team in Svalbard are in contact with the launcher.
And we can see there our speed. We are just on, 7.5 kilometers per second, so heading towards 28,000 kilometers an hour. That's pretty fast. And if you look at the thin blue line on the edge of the Earth there, that's the atmosphere, our very thin atmosphere. And of course the folk at Svalbard collecting the data from the rocket as it flies over, and they're relaying it here back to the Guiana Space Center. And here's a replay now of our launch, which was half an hour ago. We lifted off from the pad at 6:02 local time. That was 10:02 in Paris, 9:02 UTC, and it was a beautiful, glorious launch.
Yeah, amazing weather conditions, no clouds, super nice light. Wow. Super nice shot here.
Looking across there from the Vega C pad.
And I guess all people were really pleased with that condition.
Everybody went out to watch it from the terraces here at the Mission Control Center. We saw the fairing falling away.
Booster separation.
We were very lucky to have clear skies.
Yeah, indeed.
And there's the white dot there, the Vulcan engine propelling the rocket into space. And here we are again, 30 minutes now and 40 seconds into our flight. And as I mentioned, the folk at the Svalbard tracking station collecting the data from our rocket as it flies over, because it's talking to us. And they're relaying those data back here to the Guiana Space Center. And the teams there at the Quick Look telemetry, back with them. There they are. Well, that's the CDL teams, I think. Oh, here we go. On the bottom right hand of your screen, you can see the Quick Look telemetry team, back with them.
And they are in full focus here. Yeah, there is a mix of intense focus, professionalism, and of course adrenaline, as you can guess, because as we go through moments of tension, like critical phases, we just saw the video of them, liftoff, stage separations are really high tension moments, and there is high pressure on their shoulders to analyze it in real time, be able to detect any anomaly, and then react and communicate to everybody like they are doing, because we can hear the range operation manager.
And the teams at the Launch Control Center, here they are. Their job's pretty well done, because they were very much concerned with the beginning of the pre-liftoff, but now they're all waiting eagerly to hear from the Quick Look telemetry team and the range operations manager to confirm success of the mission. We're coming up as we get closer now to separation.
Yeah, and here I want to pay a tribute to one of my colleagues, Pierre Destin, who has been a technical leader for launch preparation for a number of years. And here we see Pierre, and he has managed 11 launch campaigns since 2013, being an expert in space propulsion aside of it. And this today is its last launch campaign with today's launch, so congrats and thank you, Pierre.
Well done, Pierre. Yeah, well done. 11 launches, that's a lot of launch campaigns. Getting close now to separation of our satellite. That is scheduled in just over 1 minute's time. We can see the satellite attached to what's left of our rocket pointing downwards. Samuel, what's happening up there?
So we're actually performing a number of maneuvers to orient the launcher and its passenger, Sentinel-1D, to point the right direction in space, to then separate Sentinel-1D. And this means typically pointing the solar rays, for instance, towards the sun, to to capture the sunlight and to have power for the beginning of the mission.
Extinction APU.
And then once the orientation will be reached, we'll stabilize the launcher. When it's very stable, we'll release the clamp band, which attaches the satellite to the launcher. And with 6 springs, we'll gently
Séparation Sentinel-1D.
push Sentinel-1D.
Wow, we have confirmation there.
Sure. Wow.
That Sentinel-1D has been separated. So we will see that on the image. As you say there, the springs pushing Sentinel-1D away very gently from the mothership. And we are looking at some very happy faces here in the Mission Control Center.
Yeah, indeed. That's a remarkable achievement. Congratulations to European Space Agency. First, you can see colleagues from European Space Agency here, European Commission as well, Thales, Arianespace, and all the team, industrial team who built Sentinel-1D. And also I want to say very hats off to all my colleagues in Arianespace, Ariane Group, CNES, and all the partners involved on Ariane 6 throughout Europe.
Nice work, everybody.
Congratulations to everybody.
Absolutely. Really, job well done. There we can see the image of the satellite moving away from the mothership. Those are the boards here in the Mission Control Center, the flight path on the bottom right-hand side there, and the trajectory and the green status panels. That's what...
And that's the beginning of a new chapter for them.
It's the beginning of a new chapter, certainly, for the satellite. Here are the teams in the Mission Control Center, all very happy about this. And, of course, we are sending our best wishes now to the teams at the European Space Operations Center as they are taking on their new satellite, waiting. The next phases will be for Sentinel-1D to call home and let everybody know things are going well.
To deploy the antenna and the solar arrays, as we saw in the movie before. It was clever deployment systems there, yeah.
Indeed, and there will also be at some stage, it will deploy its whopping great big antenna, great big 12-meter long antenna, its radar, which is going to be doing all that important work. But let's go over now back into the fishbowl and to David Cavaillolès, who is the CEO of Arianespace and the head of the flight desk. David, congratulations, great news.
Well, thank you, Cathy. This is indeed a great news. Tonight, Ariane 6 has successfully placed into orbit the Sentinel-1D satellite. So now this is 7 missions that Arianespace successfully delivered for the Copernicus program. So my first message would be for the European Commission, for the European Space Agency, our clients, and for all our partners. Thank you for your trust. We are really happy to have done this mission with you.
And we were very lucky. It was a beautiful launch, and everything went like clockwork. What does it mean for your teams, David?
Well, this is a great teamwork, and you can hear the team behind me. As you know, we are in an incredibly steep ramp-up, but this is a huge source of motivation for everybody. So I just want to say congratulations to everybody. And now the rest of the year will be still very intense. We have now one Vega C launch to come, then one Ariane 6 launch to come. So stay tuned, because remaining months of the year will be quite intense. Thank you very much.
David Cavaillolès, thank you very much indeed. So, congratulations to everybody. We are coming to the end of our program now, and it's been great, hasn't it, Samuel?
Yeah, congratulations again to everyone involved. It was really an important launch for us, and we are very, very pleased for our customers and for Europe, because in Europe we have a new satellite in orbit, so this is a very good thing. Yeah.
It's a very good thing, and best wishes to everyone at the European Space Operations Centre now. The job is done here at the European Spaceport, and the job is just starting for them. Huge thanks to the live broadcast teams who brought you this programme, and my thanks to you, Samuel. Thank you so much for being with us. Having your expertise means everything.
So kind, Katie. It was really a shared pleasure and honor to commentate this launch live with you, and thanks to the team as well for your huge work.
And thanks to you for watching. It's been great to have you with us. We're going to be back with you again for the next launch. If you want to stay tuned, there's a press conference in 10 minutes, so please do stay tuned for that. But for now, from me, Katie Haswell, and
from me, Samuel Rogez.
The press conference is actually, I've just heard, in 45 minutes rather than 10 minutes, so that's my fault. Stay tuned for the press conference. But from me, Katie Haswell, and from
me, Samuel Rogez, goodbye.
Bye-bye.
à tous les adjoints. Donc pour la photo de famille, on va faire au prochain trou TM. Donc je vous demande de
We are now live from Europe's Spaceport in Kourou, French Guiana, and connected to ESOC in Darmstadt for the successful launch of Sentinel-1D satellite with Ariane 6, a new milestone for Europe's space program. I'm Julie Lenoir, I'm the head of communication at Arianespace, and I will be the moderator of this press conference. Over the next few minutes, we'll hear from the leaders who have made this launch a success, before opening the floor to questions from media. But first, I just wanted to give you this great news. We just learned that the acquisition of Signal is good. So congratulations to all the teams involved. That means that the satellite is healthy and communicating perfectly with ground control. Congratulations. To mark today's success, we are now pleased to share a special message from Mr. Andrius Kubilius, European Commissioner for Defence and Space.
Congratulations. Another landmark Ariane launch, another milestone in space for Europe. The third this year. An European rocket with an European satellite. That's robust and independent, bringing European autonomy in space, resilience on Earth, and benefits to all mankind. Today, we welcome the new Sentinel-1D satellite, which makes Europe's world-class space observation even better. Looks at our planet night and day, through rain and shine, through smoke and fire. To monitor melting ice caps, erupting volcanoes, and suspicious ships. Helping to fight disasters, rescue people, and counter crime. Using space to make life better on Earth. My warmest congratulations to everyone who made this possible. European Space Agency, Arianespace, European industry, and our dedicated teams at the European Commission. And now onward and upward to the next launch, Sentinel-6B and Galileo and beyond. In space, the sky is never the limit.
Thank you to the Commissioner for these words, highlighting the importance of this mission for Europe's autonomy and leadership in space. We now continue from ESOC with statements from our institutional partners and customers. I'm pleased to invite Mr. Joseph Aschbarer, Director General of the European Space Agency, that will be followed by Mr. Christoph Kautz, Director for Space Policy, Satellite Navigation and Earth Observation at the European Commission. That will be followed by Mr. Christoph Kautz, Director for Space Policy, Earth Observation at the European Commission.
So thank you, and a very warm welcome and greetings to Kourou. Thank you for delivering the satellite safely into orbit. Thank you, Ariane Group. Thank you, Arianespace, and of course all our friends of CNES, of ESA, and everyone who has contributed to that. But also a big thank you to the European Commission. We have just heard Commissioner Kubilius, a very powerful speech, and I would like to really add my own words from the European Space Agency that we are delivering success for Europe in space. This is what is our mission. This is what we are doing. We had a number of launches already this year. We have still a few more launches to come, as we have just heard. Galileo, Sentinel-6B, Hydrogen-SS actually next week. And of course, in a few weeks, very few weeks, we have the ESA Ministerial Conference. And this context, which we have seen here tonight with the successful launch of Sentinel-1D on Ariane 6 is really a perfect preparation and backdrop to the Ministerial Conference. So I really would like to give my thanks, my appreciation to everyone who has made this success possible. It is a huge success for Europe. Europe can be very proud of what we are achieving together with the Copernicus program, with Sentinel-1D, with the launcher programs. And this is what makes Europe strong. Because when we are putting our heads together, when we work together, we can do incredible things. And this is one example of how we do it. So thank you from my side, and very warm greetings here from Darmstadt, where we have just seen the acquisition of signals both from Svalbard and from Troll. And I hand over to Christoph Kautz.
Thank you very much. And I would also like to congratulate everybody down there in Kourou for this wonderful launch, Arianespace CNES, and of course colleagues and friends from ESA. It was a wonderful launch that we could see without any clouds, and I think it's really a great night tonight, and I would like to thank again everybody, including of course also our industry partners who have developed and built this wonderful satellite. Thank you so much.
Good evening. Also on my side, great thanks to the team. We have another Copernicus satellite up and flying, Sentinel-1D, the fourth of this generation of radar satellites. This has already been a success story, not only with the Commission, but also for these radar missions in terms of providing a lot of application to users, to citizens, from maritime security to flooding monitoring to management of better everything that's related to disaster, but also looking at deforestation, looking at agriculture and iceberg monitoring. So a lot of applications coming from the satellites, and the fourth one will only reinforce us all as Europe for supporting this application. Big thank you to the team, the industrial team in premise, the project team in ESA, ESOC, for all what they're doing now and in the next few days with the LEOP operations, and of course the Commission, our primary partner in this. We work under the leadership of the Commission, and it's a very strong collaboration here. And then to everybody who has been supporting and everybody who will use the data, of course. Thanks a lot.
Thank you very much. We now return live to Europe Spaceport in Kourou. To start with, I'm pleased to invite Mr. David Cavaillolès, CEO of Arianespace, to share his remarks.
Thank you, Julie. I just want to say that today is a great day for space and a great day for Europe, because today we can say that we are fully back in the game. We are fully autonomous to access to space. Why? First, with Ariane 6, we have a launcher that is absolutely reliable. 4 launches, 4 successes. Second, we have a launcher that is incredibly accurate. There is a figure I want to share with you in exclusivity. We just got some data from the flight, and the accuracy of the injection is around 200 meters. So you must imagine a launcher going at almost 30,000 kilometers per hour, and the injection is 200 meters. So this is absolutely crazy. This is incredible. And the last point, of course, is that this is a launcher which is industrial. This year, we are well positioned to do 4 launches. Some months ago, some years ago, a lot of people just didn't believe in it. And we are doing it, thanks to all the stakeholders, public, private, in Europe. So this is very positive. This is not the end of the story. We are accelerating. Next year will be even more impressive. Everybody is really committed to make it happen. So thank you to all the people involved. We are really going in the right direction, and we are really, really proud of this success.
Thank you, David, and congratulations to the entire teams for these remarkable achievements. Let's now turn to Mr. Enrico Zampolini, VP Domain Observation and Navigation at Thales Alenia Space Italy.
Good evening. So I'm really excited to be here to celebrate this successful launch, thanks to Arianespace that put again us in the space. So now we have another Sentinel-1 in the space that will replace Sentinel-1A that after 14 years will be disposed. Now the satellite has been catched by the operation team that is trying to put him in the operation. And we are looking forward to see the first images that we should receive in the next days. So I want to thank my team that in Rome, the team that is here, that worked together with Arianespace to have this perfect launch. Let me say perfect. Thank you very much. And then I also thanks the operation team in Darmstadt that is working with our colleague of ESA. Thank you very much.
Enrico. We'll now open the questions from journalists. Let's hand over to Isaac for the local press conference. Thank you very much for watching. Here in Jupiter, let me introduce the speakers for joining us today. So you already know David Cavaillolès for Arianespace, Enrico for Thales Alenia Space. We also have Pierre Bargellini, Copernicus Space Segment Program Manager at ESA. Tony Tolker-Nielsen, Space Transportation Director at ESA. Tim Lemens, Copernicus Policy Officer at the European Commission. And Jean-Marc Astorg from CNES, Director of Strategies in the Public, and will be also happy to answer your questions. So could you please stand up and state your name and media? We will bring you a microphone. Who would like to start? Is there any questions?
Okay, Sandro Iannacone, La Repubblica, Italy. What are the elements that make you say that this launch was perfect? Why are you so excited about how it went?
David?
But we can do the answer together. So first, a lot of work is done before the launch itself. Teams have been working on the launcher, on the satellites for a year. The campaign itself lasts for some months. So this is really intense, and during all this step of preparation, it was very smooth. We didn't encounter specific difficulties, which is positive. And with regard to the launch, let's say the result speaks for itself, reaching the perfect orbit, being so close from the perfect point. This is really what makes me say that this is a perfect or almost perfect launch. Yeah.
So I'd like to underline the word cooperation, because this is the key to reach the result that we are able to reach today. So a real good cooperation between industry team and ESA and Arianespace, and so we are here to celebrate this success, thanks to the cooperation.
Other questions from the room?
Thank you, Eric Renet from newspaper Le Soir. So there won't be any Sentinel next. So what will be next?
In terms of Sentinel-1 or in general? In general. So in general, we have in a bit more than 2 weeks another launch, Sentinel-6B. It's a cooperation between the European Space Agency, the European Union, EUMETSAT, and US partners, NASA and NOAA. And NASA is procuring the launcher, and we're going to launch on the night between the 16th and 17th of November from US. And then next year we have another launch here in Kourou, planned in September, Sentinel-3C. So it's the third satellite of Sentinel-3 series. And this satellite will be launched with a Vega C in September timeframe. This is just the launches. Then we are developing numerous missions, the so-called Sentinel expansion. So the program is very healthy, and we have plans to continue the data to the users for the next decades. In total, so as I say, this year, let's say the projection we have from now until 2028, we have planned 5 launches, and from 28 to 2034, we are planning 18 launches. And maybe if I may, coming back to the injection accuracy, I'm very happy of this number, which is exceptional. And there is a benefit for the users, because when we design the satellite, we account for a certain part of the fuel to correct problems, injection errors we call, which is the normal mistakes you make in a injection. 200 meters is fantastic. So all that fuel we don't need to spend to reach our perfect orbit. We can save the fuel and extend the lifetime of the mission for years. So probably 2-3 years more lifetime in terms of fuel, thanks to the perfect injection of tonight. So great news.
Thank you.
Thank you, Camille Gessin from Agence Europe. Just to compare, you say 200 meters is fantastic. Can you explain how was the accuracy for AC, for Sentinel-1C, for example, just to compare, if you remember?
Do you know? No, you remember? I don't know.
Pardon, je t'entends.
No. I don't have the figures, but just have in mind that being so close from the target is incredible. When we define a mission, there is a range of distance that is acceptable, and when you are in the range, it's okay. But as my colleague rightly mentioned, being in the range is good because it means that the mission is successful. Being very close is even better because you save fuel, you can exploit the satellite for a longer time, so this is really a game changer. For this one, so for this, it was much more than what we did. It was much more. Maybe the client wants to share those figures, but we are clearly within the range. And you know, Ariane 6 is a new launcher, and being so close from the target at this, let's say, step of the exploitation is really an achievement. So of course now we need to ramp up, we need to confirm those very good performance, but this is very, very promising for the future.
Another question? Yes.
Dr. Zampolini, you mentioned that we will have hopefully the first images in a few days. Are those just calibration images or are real data that we can already use? And when will we have like the real data? When will the satellite be operative with all these instruments?
So the next phase will be what we call a LEOP, in which all the equipment of the satellite will be tested. The health of each equipment will be tested. Then the commissioning phase will start. We'll get the first images, and we will use these images to calibrate the instrument. And hopefully in 3 months we will get the first real data that can be used by the scientists and from all the users.
Is there any additional question in the room? Adelina, do we have online questions also? Not yet. Okay.
My name is Alexander Gurgula and I work for Gazeta Wyborcza in Poland. You sound very optimistic, and you said you have already plans for the next decades. So are you as optimistic about financing those plans in the future, and how does the perspective look like?
It's not for me.
So I'll answer part, and I will leave the floor also to my colleague at the European Commission, because this is a partnership, ESA, EU, and many others. So on ESA side, first of all, Copernicus is an operational program, is probably, I can say objectively, the most advanced and extensive program of civil Earth observation in the world, especially now with the US situation, as you can imagine, is even more so. So there is a high interest from our member state to continue the program for the decades to come. So we have now, at the end of the month, a ministerial conference where there will be the next segment of the Copernicus program funded by ESA member states. And then in 2028, there will be the start of the next MFF. So there is, at least on ESA side and the Commission side, a very good alignment on what are the needs for financial needs for the next 10 years. We are planning for it, and of course our member state will have the intention of continuing to support this program, which is so essential for many applications. So on ESA side, we have submitted our financial request, and we will get the results in a few weeks.
And from Commission side, it's a similar story, but mostly on a different time scale, because we work with 7-year periods, which are the multi-annual frameworks, financial frameworks. The current one, there everything is foreseen, and there all the launches, all the operational costs, all the service costs are foreseen. Of course, we have to look at what will come next as from 2028, and that's what we are working on now. We are now making the budget of what will be needed, what we can do with the budget that we will get, and so on. And the discussions about that will take place in the months or the years to come, so that we are sure that we have the budget starting from 2028 until 34 for indeed financing together with ESA the next phase of the Copernicus program, which is an operational program, as Pierre already said. So the benefits for the member states and for the European Commission and for the citizen is so high that it's logic that we continue, and we have a lot of support to continue and to get the budget that we need.
Thank you.
A question from Antoine Meunier, La Chronique Spatiale. It's a question for David. 4 Ariane 64 are expected in 2026, but how many next year will be dedicated to Kuiper?
Well, as usual, we'll communicate on next year manifest next year. Okay? Some hints anyway. Okay, because I don't want to disappoint anybody. As we said in the past, we want to more or less double the cadence. Okay, so this year is 4. Let's say that an ambition of 6 to 8 next year would be great. We'll start the year with an Ariane 64. It will be very exciting. It is a launcher that has a lot of common with Ariane 62, so all of the experience gathered this year, of course, will be very useful. At the same time, this is a launcher that is more or less twice more powerful. And typically for constellations, this is very relevant because with one launch, you can stack a lot of satellites, and so you can deploy very quickly the constellations. That said, Ariane 64 is interesting for Kuiper, but not only. We see a lot of clients, private but also institutional, that are interested by this launcher. So this is very positive for next year and also for the years after.
Thank you. And another question coming from our online watchers. This is a question from Jay Keegan from NASAspaceflight.com. The question is for Arianespace. There is one more Ariane 6 launch on the manifest for 2025, bringing the total to 4 for this year. What cadence do you expect for 2026? Having now flown Ariane 6 5 times, are there upgrades planned for the pad to allow for a higher cadence?
Okay, so I think I answered the first point, and maybe I can complete by recalling that our target is to reach cadence 9 to 10. Okay, and it will be in a short time frame. If we do next year more or less twice than this year, then the year after we should be quite close to this target. We think that at this cadence, taking into account the performance of Ariane 6, we can deliver a lot. Okay, in low orbit, Ariane 6 with upgrades and so on will be around 24 tons of performance. So if you multiply it by 10, it represents a huge capacity. So we think it is relevant. Now, of course, at the same time, we see more and more projects on the private side, but also on the public side. IRIS² is one of them, but many others are coming. So for the moment, our focus is to reach our target cadence. If we need to go beyond, if we think it's relevant, let's discuss it. But I think that this is the market, this is the client that must drive our decision.
Thank you, David.
Perhaps that can be completed with regards to the future of Ariane 6 and the improvements by Tony Tolker-Nielsen. Thank you.
Sure. Tony, would you?
The journalist was looking for the future improvements to Ariane 6 or upgrades. Thank you.
So, is it working? Okay. So at the moment we are working on an upgrade of Ariane 6. We call it Block 2, which is with an increased solid rocket booster loading. Today we are at P120. We will increase it to P160. And we will also increase the performance of the Vinci engine. Today it has a thrust of 180 kilonewton, and we will increase that to 200 kilonewton. This should give a gain of about 2 tons in LEO, and this should come towards end of next year. So that's what we are working on right now. The P160 has done its qualification test, so it's done, and we are now doing the analysis of this data, and we are doing a qualification review as I speak, actually. Thank you.
Thank you. Okay. Is there any? Okay, go ahead. Thank you.
Hello, Senne Starks from Belgium for the Standard. One of the cornerstones of Copernicus is that the data is publicly available. Will this also be the case for the AIS system data, which could be sensitive?
Tim?
That's a very good question. I think you have read the documentation very well. Indeed, in general, that's the point of view, that all data should be fully free and openly available. However, with AIS, as you correctly indicated, there is a sensitivity issue that we cannot just do the same for those type of data. It's not just sensing images from Earth, it's really getting messages which are sent out by vessels, and there could be personal data problems. So we are looking into this, and we will make it available for all national authorities and maritime institutions in Europe, but it will be in a secured environment, so not fully public.
Thank you. Any additional questions from the room? Again?
Okay, about the launch, Ariane 6 was, I think, powerful enough to take another payload next to the Sentinel satellite, because the previous Sentinel was launched with Vega C. So was this an option to include another payload?
Well, for the moment, we are at the beginning of the exploitation of Ariane 6. So we want to focus on what we call the main payload or the main passenger. This is why we focused on the Sentinel-1D satellite, and that's it. In the future, and we are already studying it, on some launches we will be able to have one or two main passengers, one or two big satellites, and auxiliary one, what we call auxiliary ones, meaning smaller ones. It requires additional qualification, additional studies, so we want to go step by step. Of course, our main commitment is to ensure the success of the mission. So for the moment we do what we call single launches, but in the future this is clearly something we could imagine to do, because the more we use the performance of the launcher, the better, simply.
Thank you. Any other questions? Not from online? Okay. So I guess this closes this press conference. Thank you for attending this press conference of the successful launch of Sentinel-1D with Ariane 6, and see you on next missions.